In this video, we will demonstrate the use of both Minitab and SPSS in performing the basic one-way ANOVA. We will use the experimental results of the percentage yield of a chemical reaction, which has been carried out using three different catalysts, C1, C2 and C3, and performed on 4 different days, D1, D2, D3 and D4. In this analysis, we will assume that the measurements on the 4 different days are actually replicate measurements, so that we will only be testing for the effect of different catalysts. It is useful to note that if the variable in the column is a text variable, then an additional T is added to the column number, like C2T. To run the one-way ANOVA analysis, we can go to Stat, ANOVA, and for a one-way analysis we can use one-way, and then we have the option the data may all be in one column or may be in separate columns for each factor level, but all our yield values are in one column and the response is the yield, so we click on yield and either select or we can just double click on yield. The one factor in this case is the catalyst, so we can double click on catalyst and we can just run the analysis. The results will appear in the session window. We can see we have the results of the one-way ANOVA of the yield versus the catalyst. The null hypothesis was that mean yields for all the catalysts were the same. The alternative hypothesis was at least one was different. And we can see down here that we have the standard analysis of variance output table. The catalyst row gives the variation of values between factors, i.e. between the catalysts, and the error row gives the variation of the results within each factor. There are 2 degrees of freedom for the catalyst because we have 3 different catalysts. The data gives us the sums of squares for each variability, and dividing by the relevant degrees of freedom, we get the mean square values for each of the variabilities. And the F value then simply takes the ratio of the variation, the mean square values between the catalysts, with the variation within each catalyst, and the results of the F test are then presented as the p-value of 0.024, which in this case shows that there is a significant difference between at least 2 of the catalysts. We can also perform the one-way ANOVA by using the general linear model, fit general linear model, and the response again is the yield, the factor is the catalyst, and running the analysis we find we get the identical analysis of variance output table. The data is arranged in columns. The percentage yield is the output variable in this case, and each row represents a single measurement defined by the value of the catalyst and the day. In this experiment we have 3 different catalysts, C1, C2, C3, and 4 days, D1 to D4. We have also introduced the variable cat n to define the catalysts using the numeric values 1, 2 and 3. In SPSS we can perform a one-way ANOVA in 2 ways. First of all, analyze. We compare means, one-way ANOVA. In the dialog box we choose yield as the dependent variable, and we can see that to define the factor we only have the option in this particular method of using the numeric variable. So we use the numeric variable cat n to describe the factor. Click OK, and we see the standard ANOVA output table. The within groups just represents the variation of the data within each catalyst. The between groups represents the variability in the data between the different catalysts. In each case we have the sum of squares, which can be divided by the respective degrees of freedom to calculate the mean square value. The f-test then tests for a significant difference between the variability between the catalysts compared to the variability within the catalysts. And the f-test in this case gives a p-value given under the significance column of 0.024, which shows that there is a significant difference between at least two of the catalysts. We can also perform the one-way ANOVA by using the general linear model, and in this case we select univariate option because we just have the single output variable yield, and again yield is the dependent variable, and for the fixed factor catalyst we could use the numeric description cat-n or the text description. We will use the text description as the fixed factor. We click OK. The output now gives some additional information, and this is because it is fitting a general linear model, but we can see that we have the same ANOVA table embedded here, with catalyst representing the between groups variation and error representing the within groups variation, giving the same values for sums of squares, mean squares, and the same p-value of 0.024.